Let's solve LeetCode number 121, best time to buy and sell stock. In this question, we have been given an integer array prices where each element of the prices array denotes the stock price on that particular day. We have to find the maximum profit possible by buying and selling these stocks. Do note here that the operation of buying and selling requires an entire day to be performed. You cannot buy and sell on the same day in consecutive manner. Let us try to visualize the prices array for a better understanding. Here we can use a time series plot where the x-axis would represent the day and the y-axis would represent the price of the stock on that particular day. If you try to track down any two consecutive days, you will notice that if our buying price was higher than our selling price, then we are encountering a total net loss, no profits. This is because we would be selling our stock at a lower price than what we originally bought it for. Similarly, if our buying price was lower than our selling price, we would be gaining a total net profit in the long run. Now our buying options are plenty here. We can buy the stocks on any of the given days in the prices array. But do note that to sell the stock, it can be only possible from the second day onwards. This is because on the first day, you need to buy at least one stock to be able to sell it in the future. In the given question, they have mentioned that the buying and selling operations take an entire day to be performed. Hence, on the first day, we need to at least buy the stock to be able to sell it in the future. And similarly, from the second day onwards, we can either buy the stock or sell the stock. The simplest way of solving this problem would be keeping track of all possible days to buy the stock and all possible days to sell the stock, thus creating these buy and sell pairs. The profit would be the selling price minus the buying price, and we will keep track of the maximum profit that can be achieved from all such pairs, and that would be our final answer. Let's take the first test case as an example. Here we will initialize our parent loop as the buy loop, denoting the buying prices of the stock, and similarly the nested loop as the sell loop, denoting the selling prices of the stock. Notice how the sell loop starts one index after the buy loop. This is because it is not possible to buy and sell on the same day. While we are doing this, we will keep track of the total profit achievable from these pairs of buy and sell. The total profit would be the selling price minus the buying price. While all of this is going on, we will also keep track of the highest profit achieved till that point. Initially, the question mentions that if no profit is achievable, then return 0. Hence, we initialize our highest profit with 0 in this case. Now, for our reference, let's keep track of a profit table to see how exactly the profits are being tallied. In the first case, our selling price was 1 and our buying price was 7. The total profit here would be 1 minus 7, that is minus 6. In other words, we are encountering a loss of 6. Is the minus 6 profit greater than our already existing profit 0? No. That's why we ignore this profit and go to the next case. Here, our total profit would be 5 minus 7, which is minus 2. Similarly, this is a loss of 2, hence we ignore it. Going to the next index. Here, our profit would be 3 minus 7, which is minus 4. Ignored once again. And while we keep doing this, you can notice that for the buying price of 7, we are not at all encountering any profits. If you think logically, this makes a lot of sense. Why? Because we bought the stock at the highest price possible, which was 7. And now when we try to sell it in the future, the prices are very low than our original buying price. So no matter what, we will be encountering a loss in the future. It is inevitable. Now let us go to the next buying price option, that is 1. For the buying price of 1, we can start our selling options from the selling price of 5. In the first case, you will notice that the total profit possible was 5 minus 1, which is 4. Now we are gaining a profit of 4. Is 4 greater than our existing highest profit 0? Yes, it is. Hence, we update the highest profit with the 4 value. And now what we do is we will keep track of this highest profit for all of the pairs possible in the future. Let us see what exactly happens and what is the final answer that we get. You will notice that after performing all of the possible pairs and all operations, the highest profit possible that we could get was 5. This would also make a lot of sense because we are buying it at a minimum price of 1 and selling it at a maximum price possible of 6, hence our total profit. This entire operation takes a total of big O of n star n, which is big O of n square time complexity, because we are running two nested loops within each other. Whereas the space complexity is just big O of n. In the worst case, we are storing a maximum of n elements in the array. Let's code the brute force solution to this problem. Here, let L denote the length of the prices array. Also, we will initialize our total possible profit or the maximum profit with 0. Why? The reason being that initially we are neither selling any stocks or we are buying any stocks. So the profit remains 0 at the beginning. After that, what we can do is we can run our parent loop, that is the buy loop, in the range 0 to L minus 1. If we were to buy the stocks on the last possible day, that is the Lth day, then when will we sell the stocks? You just cannot sell it. There is no day left to sell the stocks in the future. If you buy the stocks on L, then the only possible outcome that you can get from it is a loss in your net profit. And for that reason, we will be running our loop from the first day to the second last day to buy the stocks. And for each possible option to buy the stocks, we will run the nested sell loop in the range I plus 1 to L. Here we are running the sell loop in the range I plus 1 because if you were to buy the stock on the ith day, then the selling options would start from the I plus 1th day. Now, once both of the loops are initialized, what we will do is we will take the maximum profit possible from all of these pairs. That is, profit equals to maximum of current profit and the profit of the current pair, that is prices J, that is the selling price, minus prices I. Here, profit is our initialized profit right here. Prices J would represent the selling price and prices I represents the buying price. The selling price minus the buying price is the total profit for that particular pair. And we are taking the maximum possible of it to update our answer. Simple. And just we simply return the total maximum profit after all of this has been done. The total time complexity of this entire code is big O of n square because we are running two loops here to find all possible pairs and their profits. But the space complexity of it is big O of n because we are using a single array to check for all of the prices and all of the profits. If you try to submit the solution, it gets accepted for the smaller test cases, but the same solution for bigger test cases gives time limit exceeded error. Here, our solution stopped at 198 out of 212 test cases, and thus there is a need to optimize the existing solution further. There is a more intuitive way of solving this problem in just one pass. For each day we try to sell the stock, we can keep track of the minimum buying price up till that point and get the maximum profit for that particular day. Let's take a step-by-step demo on the previous case to implement the logic. Here we will be traversing through the prices array and keeping track of the stock prices on each individual day. While we are doing that, we will also keep track of three things: the selling price, the minimum buying price, and the maximum profit. The selling price here denotes the price of the stock on the day that we decide to sell the stock. The minimum buying price is the minimum possible buying price of the stock till the day we decide to sell the stock. Now, why exactly are we keeping track of this minimum buying price? Because selling price minus the minimum possible buying price would give me the highest possible profit. And for this reason, we keep track of the minimum buying price. The third thing we keep track of is the maximum profit till the end. Let's go one step at a time. On day 1, our selling price would be none. But why is it none? If you recall earlier in the question, they had mentioned that you must buy a stock first in order to sell it in the future. On the first day, Without buying any stock, we cannot just sell the same stock. And you cannot buy and sell on the same day continuously. That's why our selling options only start from the second day onwards. But what is possible on the first day? On the first day, we can either buy the stock or completely ignore it. And we will set for that reason our minimum buying price equals to 7. The initial maximum profit here is 0 because there is no buying and selling going on the first day. Now we go to the next day. On the second day, our stock price is 1. What is the maximum profit I can get by selling the stock on the second day? That would be my current stock price on the second day, which is 1, minus my minimum buying price possible till that day, which is 7. 1 minus 7 is minus 6. And by minus 6, we can note that there is a net loss in the profit. There is no profit going on. We are actually losing money instead of gaining money. And for that reason, what we will do is we will update our max profit accordingly. Is 0 greater than the net loss minus 6? Yes, definitely. That's why we'll say that the max profit till the second day is still 0. But what extra will we do after that? What we will do is, suppose if we had not sold the stock on the second day itself and we keep on going to check for better profits in the future. Is the option of buying the stock at a price of 1 better than buying the stock at a price of 7? Yes, most definitely. So what we'll do is we will update the minimum buying price to the value of 1 for future use. Now we go to the next day, the third day. On the third day, our selling price becomes 5. What is the maximum profit I can gain on this day? That is 5 minus the minimum buying price till that point, which is 1. So 5 minus 1 equals to 4. Notice how because we use the minimum buying price this time, we are gaining much more higher profits. And for that reason, we will update our maximum profit from 0 to the new value, which is 5 minus 1 equals to 4. Till the third day, I can get a maximum profit of 4 stock units. Now similarly, like the previous day, we will update our minimum buying price options, which is the minimum buying price 1 or today's stock value 5. It is definitely 1. So we will keep it at 1. Now going to the next day, day 4. On day 4, our selling price is 3. What is the maximum profit I can gain? That would be the today's selling price 3 minus minimum buying price 1. 3 minus 1 is 2. Is the profit of 2 greater than the profit of 4? No, it is not. So we will keep the maximum profit still at 4. And also we will check, is it profitable to buy the stock on day 4 instead of just selling it? To buy the stock, we would require a total price of 3 units. Is 3 units cheaper than the already existing 1 unit? No, it is still not. So we will keep the minimum buying price still at 1 units. Now going to the next day, day 5. On day 5, our selling price is 6. What is the maximum profit I can achieve on day 5? That would be my selling price minus the minimum buying price up till that point. That would be 6 minus 1 equals to 5. Is the profit of 5 greater than the profit of 4? Yes, it is. So we will update our max profit accordingly. Now our max profit is 5 for selling the stock on day 5. And similarly, like the previous turns, we will update the minimum buying price with the minimum of the earlier existing buying price and today's stock value. Now going to our final day, day 6. The selling price on day 6 would be 4 units. What is the maximum profit I can gain on day 6? That would be my selling price minus the minimum buying price till that point. 4 minus 1, which is 3. Is a profit of 3 greater than the profit of 5? No, it is not. So our total profit still remains 5 and the minimum possible buying price still remains 1. And thus we have completed the entire prices array and achieved at the final answer. The final answer would be whatever max profit we have at the end of the traversal. In this case, it would be 5. The overall operation of performing this entire code takes a total time complexity of big O of n because we are just running a single loop from the start to finish and updating the values accordingly. The most interesting thing about this entire procedure is that it takes a space complexity of just big O of 1 or constant space complexity, which is a great improvement. The reason being is we are just using variables to store the maximum profit or the minimum buying price. Let's code the one-pass solution to this problem. Initially, we can say that our maximum possible profit was 0. The reason being that on the first day we will not be selling any stocks, hence there is no profit. Also, we can say that the minimum possible buying price till the first day would be the stock price of my first day. If you remember earlier, on the first day, there is only an option to buy the stock. We cannot sell the stocks because according to the question, buying and selling operations must occur on different days, and before selling, you also must buy the stock initially. For that reason, our initially the minimum buying price would be the price of the stock on the first day, that is price is 0. Now once that is done, what we can do is we can run a loop, that is the sell loop, in the range 1 to length of prices. Now please pay attention here. This entire loop is our selling loop. What that means is for each day or each index I, we will try selling the stock on that day. Now if you remember earlier, our selling options only start from the second day to the last day. And that is the reason why we have taken the index 1, which represents the second day. And the length prices would represent the last day of our entire prices array. So now once that is done, I can say that my selling price for that ith day would be the stock price on that particular day. Correct. I will be selling the stock with the price of prices I for the ith day. Correct. Now what would be my profit or my total maximum possible profit till the ith day? That would be the maximum between my current profit till now and the profit gained by selling the stock using the minimum buying price till that point. I will repeat it once again. The maximum possible profit till the ith day would be the maximum of my previous profit till that day and the selling price minus the minimum buying price for the ith day. Cool. Now once that is done, we will update our minimum buying price by taking the minimum between the current buying price and the current stock price. Why have we done this? Suppose we have already taken the maximum profit possible for the ith day. Now after that, we will be selling the stocks from the I plus 1th day, right? And for the I plus 1th day, we will simply be using the minimum buying price that has been accumulated till the ith day. In other words, if you wanted to sell on the 3rd day, then you would be using the selling price of 3rd day and the minimum buying price till the 2nd day. After this, what remains is we will just simply return the maximum possible profit that we gained during this entire process. That's it. The time complexity of this entire code is big O of n because we are running a single loop, that is the sell loop, in the range 1 to n. And the most interesting part, that is the space complexity, is big O of 1 or constant. The reason being we are just using two initialized variable, that is the profit and the minimum buying price, to keep track of the entire operations being performed during the entire traversal of the array, and hence there is a big optimization in the entire runtime. Now when we run this code for the same smaller test cases, it gets accepted as earlier, but in this case it also gets accepted for the larger test cases because it is using only big O of n time complexity to run the entire code, whereas earlier in the brute force version we were using big O of n square. Hence there is a big optimization in the overall performance. That's it for this video guys. Thank you so much for watching, and I will see you in the next one.